Section 4.3 is entitled Congruent Triangles. But before we talk about congruent triangles, let's talk about congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. And when we're talking about parts, we're talking about angles and sides. So, given these two quadrilaterals, angle A is congruent to angle E, B is congruent to F, angle C is congruent to angle G, angle D is congruent to angle H, side AB is congruent to EF, BC is congruent to FG, CD is congruent to GH, and DA is congruent to HE. So, we would say, since all of their corresponding parts are congruent, all the corresponding angles are congruent, all the corresponding sides are congruent, we would say that polygon ABCD is congruent to polygon EFGH. We call this a congruence statement, and the order of the letters does indeed matter. Since A is the first letter in the first polygon and E is the first letter in the second polygon, that means that angle A has to be congruent to angle E, and so on. You can also do this with sides. If I was looking at side BC, that has to be congruent to side FG, because they're both the second and third letters in each of the congruent statements. Now, congruent triangles. Two triangles are congruent if and only if their congruent parts are congruent. And actually we're going to be spending most of our time, in fact a good bit of the rest of the chapter, on triangles. So we're going to focus more on this. And this is a really cool theorem. It's got a really cool abbreviation. It's CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. We'll be using that a lot in the next couple sections. What this says is that if triangle ABC is congruent to triangle DEF, then all of their corresponding parts are congruent. Angle A is congruent to angle D, angle B is congruent to angle E, and so on. And then segment AB is congruent to segment DE, and all of their corresponding sides are congruent. Also, the converse of that is true. If the corresponding angles are congruent, if angle A is congruent to angle D, and so on, and side AB is congruent to side DE, and so on, then the two triangles are congruent. If the triangles are congruent, their corresponding parts are congruent. If their corresponding parts are congruent, then the triangles are congruent. So let's take a look at this example here. And I didn't actually write what we're supposed to do. We're supposed to find x and y, given these two triangles. So we're told that triangle ABC is congruent to triangle DEF. So that means that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. In other words, because they're in the same place in the congruence statement up here, those angles would be congruent to each other. So let's go ahead and start with that. And in fact, angle F is what I need to find. And just looking at the congruence statement, I can see that angle F has to be the same measure as angle C. So the measure of angle C has to equal the measure of angle F. And angle C is 40, and F is 6y minus 14. So 6y is equal to 54. So y equals 9. Okay. Now, in the same way, notice I have an x here. Oh, actually, it has an x and a y in it, so it's a good thing I did my y first. And so segment DE is the one we have to find, and DE, since it's the first two letters, corresponds to AB. So AB is equal to DE, and AB is 7.5, and DE is x minus 2y, and I just found out that y is 9. So 7.5 equals x minus 18, and adding 18 to both sides, x is equal to 25.5. The third angle theorem The third angle theorem says that if two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent. You can actually prove this, but it actually kind of makes sense. If angle A and angle D are the same, if angle B and angle E are the same, and I know that all the angles add up to 180 in each triangle, then angle C has to be congruent to angle F. So if you know two angles of one triangle, and you know that the two triangles are congruent, then you know that their third angles must be congruent as well. So let's take a look at a proof here. So we're given that all of this stuff is true, and I'm going to actually go ahead and mark that on the diagram as we go through. Angle A is congruent to angle E. Segment AB is congruent to ED. BC is congruent to DC. And AC is congruent to EC. I think it's really important when you're doing a proof, and especially since we're going to be getting into some triangle proofs, mark whatever is given on the triangle. And if you can, mark it in a different color. I think it'll stand out. So let's take a minute and put all of this given stuff in here, since that's our first, always our first step. Okay, and my reason is given. Oh, I didn't even say this, but so what we're trying to prove is the triangle ABC is congruent to triangle EDC, that these two triangles are congruent to each other. Well, what I'm noticing is that I have the three sides of this one congruent to the three sides of this one, but then I also need to know that all of their corresponding angles are congruent. I need to know that angle B is congruent to angle D, and that this angle C, angle ACB, is congruent to angle ECD. And actually, I do know that those two angles are congruent because they are vertical angles. So I can go ahead and mark those. And let's go ahead and name those. So I would call that angle BCA is congruent to angle DCE. And that's because vertical angles are congruent. Okay. Now I have two angles of this triangle on the left congruent to two angles of the triangle on the right. So I can say that their third angles are congruent. That is that angle B is congruent to angle D by the third angle theorem. Remember that said if two angles of one triangle are congruent to two angles of another triangle, then their third angles must be congruent. And that's the third angle theorem. Okay, so now I have all three angles of triangle ABC are congruent to all three angles of triangle EDC, and all of the corresponding sides of ABC are congruent to all of the corresponding sides of EDC. So now I can say triangle ABC is congruent to triangle EDC by CPCTC, that corresponding parts of congruent triangles are congruent. All of the angles of this triangle are congruent to the angles of this triangle, and all of their corresponding sides are congruent, therefore the triangles are congruent. And let's take a look at another proof here. Now we have something that looks like a parallelogram kind of sliced in half, and we're given all sorts of information, so I'm going to go ahead and mark that. AB is congruent to DC, AC is congruent to DB, and angle A is congruent to angle D, and angle ACB is congruent to angle DBC. Okay, and I have to prove that the two triangles are congruent. So let's take a minute and list all of that in our first statement. Let me say a word about this last angle that I was writing, angle ACB and angle DBC. Notice that I can't refer to this angle down here as angle C, because there are actually three angles that have C as its vertex. This small one I've marked here, the small one kind of above it, and the large angle C. So I cannot call it angle C because I wouldn't know which one I was talking about. So I have to use the three letters A, C, B. And the same thing is true with this little angle up here, angle DBC. I can't just call it angle B because there are three angles that have B as its vertex, as their vertex. Okay, so my reason for that is given. Let's see, so I'm trying to show that all of the parts of one triangle are congruent to all of the parts of the other triangle. Well, I'm noticing that both triangles share this line in the middle right here. So that's actually a part of both of them. So this is a little different. I'm going to say segment BC is congruent to segment BC. That the segment is congruent to itself. And that is the reflexive property. Now, why do I need to say that? Because anytime I'm doing a triangle congruence theorem, I have to make sure that I'm actually stating in my statements all the parts. Notice I have two pairs of sides here that are congruent to each other. I have to actually state that is congruent to itself to be in there. And this is the one time I think we're really going to be using the reflexive property, is in triangle congruence theorems. And then the last thing I have to do is show that this angle B up here is congruent to this little angle C down here. And to do that, I am going to use the third angle theorem. So angle ABC, maybe I should mark that first so I can see it clearly. I'll put three little arcs on that, and three little arcs on that. So that's triangle ABC is congruent to triangle DCB. And that is the third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent. And actually, I think I have all of the parts here. So triangle ABC is congruent to triangle DCB, and that is by CPCTC. Corresponding parts of congruent triangles are congruent. And you're probably wondering why I have a fifth step, because I think when I wrote these notes, I think I split up the two parts of the given instead of putting it all together in there. But that's fine. So we can just leave it like that, because we're done. And the last thing I want to go through is a couple properties of triangle congruence. The same reflexive, symmetric, and transitive properties that we've seen before with angle measures and angle lengths and all sorts of things like that. So the reflexive, triangle ABC is congruent to triangle ABC, of course. Symmetric, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And one of my favorite, the transitive property, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI.